everybody to our Rutronik webinar series, Rutronik Connects. Rutronik Connects is a 4-week webinar series where we are hosting together with our suppliers. This is the last week where we will focus on Bluetooth technology and the next generation of BLE devices and their advantages. You will learn how applications are benefiting from adding Bluetooth LE connectivity. This webinar, we will focus on upgrading your BLE capability with our supplier Inside SIP. We will look at the next generation of BLE devices based on Nordic's new nRF54 series and the nRF54 platform, which offers improved performance and capabilities across a wide range of features, whilst retaining a diverse range of products from highly sophisticated to entry level. Inside SIP will introduce their new module solutions and the simplified upgrade path from previous nRF52-53 generation products. My name is Heike Kubisch and I'm a corporate product manager within the wireless department of Rutronik. Today, I would like to welcome Nick Wood from Inside SIP, our long-term partner for wireless modules. Before we start, some practicalities at first. The duration of our webinar will be around 1 hour today. Questions can be typed on the right sidebar and we will answer them at the end of our presentation. And don't hesitate to ask questions. We are encouraged if you ask some. And in addition, the presentation will be recorded and afterwards you will receive the slides from us. So, hi Nick, are you there?
I'm here, yes.
Super. Then you can take over, share your presentation and start.
Okay, let me just put up the... So are you seeing my screen now?
Yes.
Okay. Okay. Yeah, so I'm going to talk about next generation Bluetooth solutions, and in particular our modular offering. So just to summarize what I'm going to talk about, so our Bluetooth modules are all based on Nordic Semiconductor. You may already have heard directly from Nordic Semiconductor about their new devices. I don't really intend to rehash all of that, though I will obviously have to explain the basics of what those new devices offer. So I'm going to focus on our modules that will be based on these, talk about why modules are a good idea, and why the modular advantage is in fact growing. I'm going to talk a little bit about the Bluetooth 6 upgrade, and what that offers, and in particular the channel sounding technology, which is the most striking feature of Bluetooth 6, I would say, and then talk a little bit about the applications for these devices, and then about migrating from the sort of existing nRF52 type products and what there is and what there isn't on the new modules and the old modules, and how you might want to do that. So we put a lot of thought into making that a very easy process. So just to jump right in, introduction to the nRF54 series and our solutions. So just go to the Nordic chips. Basically, they have 2 devices, but they have distinguished this L series and the H series. So the L series is I would say basically an upgrade on the previous generation of nRF52 type devices. So just giving you more in all dimensions. I'll talk a little bit more in detail about exactly what you get and what you don't get. But more memory, faster, lower power, just better all round. It's a next generation. Both of these are based on an upgraded silicon node, so it's down to a 22 nanometer node. That gives you a lot of advantages to make better devices. But the nRF54 is hitting the same target as the nRF52 series by and large, the 54L rather, and then the nRF54H is definitely a step up in capability, sophistication, features. You have all sorts of extra capability here. It's a complex multi-processor device, multi-core device. Sorry, with separate cores for the radio, for the application, for the security, for the peripherals, so this is a sort of real top-end device that allows you to do new things or replace multiple components. So on our side, we'll be following both families. So the ISP2454 is based on the 54L. So this will be in our standard 8x8 millimeter form factor. So that's exactly the same as the nRF52 series. And as far as possible, we'll design it to be pin compatible with those products. When I say as far as possible, there are different I/O counts. So, obviously you can't make something identical on the pin out if one's got 20 I/Os, the other's got 30 I/Os, but otherwise all the basic pins like power, etc., they're all in the same place. So we'll talk about upgrading, but it's a very simple upgrade. And like all of our modules, it'll come complete with all crystals, with matching, with antenna, DC-DC support, etc. So literally you put a coin cell battery on the back of this, and you've got your BLE node transmitting over the air, working, and so on. For the H series, we haven't quite finished the analysis, but we estimate we're going to have to make this, unfortunately, a slightly bigger device, simply because it's a much bigger chip. It's a complex multi-core chip, as I said. It's got more I/Os, which you've got to route out somehow or other. So this will still be very small, but it'll be more like a 10 by 10 as we're currently thinking, but that is to be confirmed. So again, same philosophy in the sense that everything's in there that should be in there. So you've got all the crystals matching DC-DC. So again, it's just a question of attaching your battery, and off you go. It's a working Bluetooth node transmitting over the air, connecting, and so on. So just talking a little bit about why modules, what advantages modules give you. I'd say we see it very much as an engineering approach. You've got a proven component that works, it's tested, it has multiple points inside. So you're getting the benefit of all our RF expertise, and RF is basically what we do. So you should get a better result with our modules than you're likely to get from designing yourself. You've got a single component that we test every single module, so you get a better yield. You simplify your own supply chain, build complexity. So, depending on the model, our modules can have up to 50 components inside, and so we have one fully tested, individually tested device that you will receive. So then that helps you get to market faster. You have a simpler development, you have lower risk, and can focus on the unique features of your own application, because getting RF that works is not going to be a unique feature of your application, but whatever specific application is being tackled will be, and it's better to focus your own resources on those activities. So all our modules come fully certified by default for Europe, US, Japan, and many of them have other certifications as well. And we can always talk to you if you have a particular need to certify your product for somewhere a bit more not quite as mainstream, for example, then we can easily arrange for those products to be certified in a territory that interests you. So we've had several customers who say, I need my product certified for, I don't know, Argentina or somewhere, or other, some particular country. Yeah, we can also sort that out for you and take that burden off your hand. And I just also point out the H series device is only available in the WLCSP, which not all contract manufacturers find very easy to handle, and that can cause some difficulties. Whereas ours will be packaged in an LGA package, so it's a much easier package to handle from a manufacturing point of view when you come to put your own product together. So there are a number of advantages there. So certification is an important point. As I mentioned already, the markets that we certify for, but the certification can be more complex than you might think, because even if your device basically works fine, it's quite easy to have some little resonance that puts you out of spec on some harmonic of your RF performance, and therefore you have to then go around the loop again and work out how to fix this. So it's not just a given that you put together a reference design and switch it on and it'll just go through certification automatically, because it's quite easy to have little odd things that can get in your way. So it's another task that takes time, takes effort, and in many cases our customers don't really want to be bothered with. So it's a good thing to have pre-done. And also the rules change. The rules get updated, standards evolve, and we update our products when there's a new regulation. The Europe in particular likes adding a regulation a year, it seems. So we keep our products updated and current. And again, it's something not necessarily that you want to keep track of, to be wondering, dealing with that. A further point is, as these products get more complex, then certification also is getting more complex. So you have multi-protocol devices now. We're not just talking about Bluetooth, but we have Thread protocols that run on these devices, which is great. You can do more sophisticated devices, but Thread doesn't use exactly the same radio scheme as Bluetooth. So it requires a different certification to Bluetooth if you want to run Thread. It's not just a question of doing the Bluetooth certification. You have to do a Thread-based one. ANTS Plus, if you want that, it also has its own channel scheme. That's also something that we can look after. Some of our products are ANT Plus certified as well. If you want to run Matter, that's not an RF modular certification type issue. It's an application. If you want Matter certification, it's an application level, but that requires Thread. So you have to have Thread as certification or support for Thread to run Matter. So there's becoming more to do if you want to have one of these multi-protocol sophisticated devices. Certification becomes a bigger job. There's also in the European scheme requirements to be able to upgrade your devices to fix security issues. So whilst that's not really an RF issue, it is something else that is being added, which is one of the reasons you need more memory and stuff on these devices. But also we have the capability to organize an over-the-air update from external memory if you need to do that, and that's something we can also support you with. And yeah, the other thing as a module supplier we offer is, in particular, is additional support on RF issues. There are often people find, oh, they put the module on the board and they build their application, and somehow it's not working very well. Doesn't mean there's anything wrong with the module per se, but sometimes the way they've designed their casing, or they haven't, there are mistakes you could make. So we're happy to review layouts and check that you're not making those mistakes. And sometimes you have very odd problems that are not obvious. There's no, it's been designed perfectly correctly, but for some reason you've got some odd resonance in the board that causes a problem. We've seen that occasionally. So customers, it's not obvious, they're not making any obvious mistakes, but when we've done detailed simulation for our customers, it's revealed that there's some, say, peculiar resonance around the board that's causing a problem, and we have the skills and capability to track those things down quite fast. And that's part of the service you get from us as a module supplier, and that's not something, say, Nordic will help you with, because they're concerned with the chip level, if not the RF design on your board. It's just not really their thing. So I think there's quite a few advantages there for the modular solution. So just moving on to Bluetooth 6 and what it's about. What are the key features? So there's channel sounding, which is a new distance measurement technique, and this is the standout feature, I would say, of Bluetooth 6. I'll talk about that a bit later. So otherwise, there are some rather technical improvements. I don't really want to go into detail about this. You can read about them in more detail if they're interesting, but there's some things to improve the advertising efficiency, so you don't have to spend so much time advertising or being receptive to advertising by scanning multiple channels. Essentially, it simplifies that. There is some improvements for reliability for the streaming, the streaming type, what Bluetooth calls isochronous transmission. This is basically what came in with the BLE audio, the underlying technology to support audio streaming over BLE. So there's some enhancements there that can improve things a bit. Some improvements to the link layer to allow devices to be a bit cleverer about working out what each device supports for optional features, and some features to improve data throughput. But I don't think I'm going to go into going into too much detail about those rather technical improvements. But the channel sounding is a distance measurement technique. So Bluetooth has a few of these distance positioning technologies, and this is the most recent. So what is it? Well, there are two different methods included in channel sounding. So there's a time of flight measurement. So this is where you send a pulse, you measure the time between two devices, send a pulse, and then immediately send the pulse back, measure the time. Knowing the speed of light, you can then work out what distance that corresponds to. And then the other is what they call phase-based ranging. This is where you measure the phase difference measurements across different channels within the Bluetooth spectrum. I'll talk about each of these in a bit more detail. One thing to note here, though, is that the Bluetooth specification just only defines these basic methods. It doesn't tell you anything about what you might do to combine them. That's really up to the application software to do. So it's kind of more of a. There are also lots of options with the phase-based ranging. It's worth adding. So it's more of what I would call a toolbox of techniques that have to be put together by an application rather than a sort of ready-to-go spec of how to do this. So for the time of flight, it's a fairly classic sort of type of measurement. So you first establish a connection. Then you send a packet from, in Bluetooth they use the terms initiator and reflector. Other measurement techniques talk about anchors and tags, but it's the same thing really. So you send a packet from the initiator to the reflector. You return that packet with a known turnaround time that has to be quite small. And then you convert that round trip time into a distance using the speed of light. What are the potential issues with this? Well, you're still using fundamentally a narrowband signal. So what that means is it's not necessarily that easy to establish exactly when a pulse arrives. When you have a narrowband signal, that means it's not sharp and well defined. So you're only going to get a certain level of accuracy with that. It also you need quite precise timing on both devices to know how quickly you're turning your pulses around and to measure the time. So you need accurate clocking. And reflections in the environment here are potentially problematic because they can muddy what you perceive as the arrival time of your pulse. So that's the time of flight part. So then the phase-based measurement, this is kind of quite clever, I guess. So in Bluetooth, you have 40 channels or 39 channels, I think, each of a slightly different frequency. So it basically has these channels separated by 2 megahertz in the 2.4 gigahertz spectrum. So when you have a different frequency, if you transmit a signal, then the phase at a particular point if you compare these two signals at a particular point in space, then you'll see the phase is different. So the different frequency will have a different peaks and troughs in the waveform at different places. And if you can measure this phase accurately, then you can also find a distance by using this technique. So this is also a way of measuring distance. So that's what phase-based measurement is. Now, what are the issues? You're detecting quite small differences here. So you can use multiple channel combinations to try and make this more accurate. So you've got 40 channels, and the phase difference in itself doesn't give a unique solution because phase is, if you like, circular. So with multiple signals, you can kind of resolve that, but it makes quite a complex measurement. So what can we say about it? So the kind of broad principle is you get a very rough measurement, but one with some security using the time of flight method, and then you should be able to have a more accurate measurement by using this phase-based ranging. What kind of accuracy do you get? Well, kind of 0.5 meter is the ballpark people are talking about. There are many options, as I said before. So exactly how you do it and how many exchanges you do will affect that. People talk about using multiple antennas to have multiple paths, which might aid the accuracy, but of course that adds a further layer of complexity. And how this will respond to environments where you might get reflected signals is to be determined. So what can one say? Well, till we've got some fully operational stacks, we can't say a lot. I mean, it's quite clever. It looks like it could work quite well, but we really have to see. The angle of arrival technology, to be honest, didn't work that well in many cases. So it could well be in some applications it's good enough. It's good enough. It's not going to be as accurate as a ultra wideband technology. It's probably not as resilient as ultra wideband technology, but as it comes kind of for free with a Bluetooth device, it's it'll be significantly cheaper. So it's going to be a question of trade-offs, and then it's going to be a question of seeing how well does it really work in practice in particular environments where you might have some reflections off walls and ceilings and floors and whatever. So that's the conclusions as we can see them today, at least for channel sounding. But it'll be a while before we have stuff we can actually test. It's not coming tomorrow, let's be clear. So, what are these new generation devices? Well, what are they good for? Well, our ISP2454 is pretty much anything you can do with an nRF52, but it'll be better. There's more RAM, there's more flash, so you can put more sophisticated applications. You can put more software stacks on the same device. If you can add over-the-air upgrade capability with the extra memory, it's got better power consumption. You've got better security. You've got a full trust zone. The H-based device, the ISP2554. So if you've got really high security demands, that's going to be well supporting. It can do also things like edge computing, even simple AI things on the front end, advanced wearables. It's got a very powerful set of peripherals, so all sorts of things like that. So just talking a bit more in detail about the 2454 based on the L series. What are you getting? Well, you're getting a better processor, the M33, and it's running at double the speed, or you can at least run it at double the speed. So that's a very clear upgrading processing capability. It's got more flash than any nRF52 series, so it's 1.5 megabytes. It's got RAM compatible with the top end of the nRF52 series, and it's got this channel sounding technology. If it works sufficiently well, you could look at it for keyless entry type solutions and things like that. What's missing? Not much, but the top end modules based on the nRF52 are 1807, which is based on the 52840, has more IOs. So if you really need lots and lots of IOs, it's not going to be a direct upgrade. It doesn't have a USB peripheral, which some of the nRF52 series do, this one anyway. So you'd have to do that externally with a separate chip if that was a critical part of your design. So in terms of migration, as I said, it's the same footprint, it's the same pinout, apart from the fact that, as I mentioned earlier, the 1807 has extra IOs, so obviously you can't match all of those just because the 2454 doesn't have as many IOs, so it's just impossible. And so it really would be just then a question of putting it on the board and replacing in most cases, or many cases. The only issues that are the most obvious ones are if you were using a soft device, one of the Nordic soft devices before, you have to move to the Zephyr NRF Connect application environment, because these devices don't support the soft device architecture. So you would have to migrate your application, and could be some of the limitations in the GPIO mapping, which I can't confirm any details, but you may not have the sort of complete flexibility to multiplex all functions to any GPIO. There may be some limitations. So you get a lot of extra performance and features. I guess if you've got something already in production that's working well, is there a really strong there are some advantages to upgrading. You get better power consumption as well. So but I guess it's probably most customers will be thinking more about when they do the next generation of product. It's a very natural replacement path. So yeah, just going on the reasons to upgrade, it's probably going to be a little bit cheaper than most of them. It should have better battery life because it's got better power consumption. It's got much better security. You've got PSA level 3, full trust zones, secure key storage, etc. So yeah, you get security features that weren't present on the other ones, and that sort of security is becoming quite important. You've got space for sort of more other stacks like Thread if you want to use those. It's going to be faster. It's got better ADC resolution. So those are the reasons to upgrade in terms of technology. As I say, I guess a lot of people will be looking for replacing it as a next generation sort of products. The applications for the 2554, which is based on the H series, so this is going to be a very big, powerful device with something of a price tag to match, I guess. So this is for doing very sophisticated things. What might you want to do with this? Well, you might be able to replace multiple items on the BOM. You've got separate radio and application processors, so you might be able to remove a processor from the system. You have extra memory, so you might be able to remove extra memory. You might have security features integrated in there that mean you can take off some components. It's got some additional interfaces like high-speed USB. It's got a CAN bus, so CAN is used. It's an automotive technology. Now, this is not an automotive qualified product, so it's probably not going to go into a mainstream, production car. But CAN is used in all sorts of other sort of vehicles like scooters or electric bikes. There are a lot of them use CAN buses, and those don't tend to have the same requirements for automotive quality products. So machine learning is quite an interesting one. You can load these ML models onto a device like this and get some, basic AI functionality, or even on these devices. So things like maybe voice commands or image recognition. These sort of applications might well be possible, and if you can do these what was called computing at the edge, where you do it on the device, you don't get the same latency. If you've got to go up to the cloud somehow, that can be in the best will in the world, you can always have latency. You can create a lot of data traffic that's can slow things down. So there's quite a lot of interest in this sort of thing. So the idea is you train your model on a big device somewhere off, and make your model, but then you load the model on to do some particular sort of AI tasks on the device. And, this sort of thing is quite interesting and not something you could have thought of doing with early generations of devices, or anything that just requires intensive computation or has you could, if you want to do some sort of advanced wearable or complete some other sort of unit, you might well find you can run really pretty much everything off this device, and you don't need lots of other components around it. And like the sort of dual core, like the NR53 series as well, you also can have flexibility with the radio and the application, switching the different elements on and off to manage the power effectively. So that's pretty much it. What do we got to offer? These next generations offer a wide range of capabilities. So for everything from just a very straightforward upgrade on most parameters to what you have already, to really cutting edge next generation capabilities. We're supporting both families, and I mean, I don't think it's, these aren't going to be the end of the story. There'll be, various other products coming in the future. I can't say what they'll be exactly, but there'll be variants on these devices and these basic families, and our modules offer an easy way to support them. We will always endeavor to make our products compatible, so if you want to change models, it's very easy to do. Just by most cases do pin compatible replacements, and as these new ones arrive, we'll obviously produce modules based on those as well. So that basically brings us to the end of my webinar. I'm obviously happy to take some questions about anything I've said, and yeah, please fire away.
Super, thank you, Nick, for your presentation, and then we will follow up with the Q&A session. So yes, there are some questions. Question number one is, what is the difference between your module and competitors?
Yeah, that's always a hard one. I mean, because most modules are, really attempting to do the same thing. I would say that our modules all use system and package technology, which is, I think, offers some advantages. It allows us to make them very small, very low profile, they just fit neatly on the board, and that is a very high quality manufacturing technique. It's kind of sits between what normal PCB assembly and sort of chip manufacturing, if you like, in terms of the sort of technology, and that means it's very repeatable, which is quite important in RF, because if you're printing an antenna, you definitely want it to be precise. So it's a very high quality manufacturing technique, and yeah, we've been working on RF and that kind of design for a long time. So I'm not here to knock anyone else's products, but I know ours have excellent RF performance, and our customers are very happy with it. We also always aim to add everything. So in terms of the timing crystal, that might be optional, or so you really do just add a battery and it works. And we've also worked on making our range very consistent, which I don't think anyone else really has in the same way, in that all our products on the 52 and even the new one based on the 24L are the same pin out and form factor and everything. So I'd say those are the main points. Yeah.
Okay. Then next question, to what degree are your modules compatible with nRF52, 53 products?
Yeah, well, I mean, I think, so, you know, sort of alluded to that in the last question. I mean, certainly the 2454 is meant to be a sort of plug-in upgrade as far as it can be. So yeah, the idea is it just slots in. I mean, I say if you take the top end nRF52, it's got 46 IOs. Well, that's more IOs than on the other one, so you can't match those. But you know, that aside, and some things like a dedicated USB pin on some models. Otherwise, you know, everything's in the same place, and you just put it on the board. And you know, some people, it really would just be a question of putting it on the board, and it's fine. You know.
Yeah. Okay. Then the last question: Are nRF52 products now obsolete?
I mean, firstly, we've got a lot of customers who've got the products in production, and a lot of them probably won't see enough reason to change, because you know, changing anything is always, you know, if they want to change, we try to make it as easy as possible. But a lot of people don't want to, you know, if it's there and it works, why change it? So I think we'll be producing a lot of these. We're producing these modules for many years to come, because a lot of people have got established production, especially for people like in things like medical devices. You know, you don't want to change anything, so there'll be plenty of customers wanting to keep going with those. There's no question of them, you know, us not producing them. If you're starting a new design today, a lot of people will move to an L series, yeah, once it becomes fully available. At the low end, it's probably, you know, if you just have some quite simple requirements, then, you know, the most basic nRF52 is still going to be a bit cheaper. So if that's all you need, you know, fair enough, you know. But yeah, I mean, I think if you're starting a new design today, or say in 6 months, when hopefully this thing will be in proper full production, for a lot of application, you'd probably jump into the new one. Yeah, I mean,
that's right. Yeah. Okay, good. Yes, that was the last question. So I will hand over again and follow up. So yes, for more information, you can also find more on our Rutronik webpage, rutronik.com, and on our Rutronik web shop, Rutronik24, or on our technical engineers community platform, Rutronik Tech. If you are interested in more electronic news, feel free to register for our monthly newsletter or follow us on social media. Yeah, if you have further questions, don't hesitate to contact me, your local Rutronik sales manager, or use our contact form on rutronik.com. The presentation slides and the recording will be sent out afterwards. And of course, you're welcome to join our last webinar tomorrow with our supplier Infineon, and with their product and solution overview of BLE devices. It is still time to register there. When you missed the webinar before, you can watch it afterwards on demand at rutronik.com. Yeah, so thanks again, Nick, for your presentation today. And for the audience, have a nice day today. Bye.
Bye.